We're going to talk about energy, special topic C. Energy is defined as the ability to do work, and it is measured in joules. It's important to remember that energy is neither created nor destroyed, but it can be converted from one form to another. For example, from potential energy to kinetic energy. As we go through this unit, please keep in mind that those conversions usually result in a loss of energy, and that's typically to the surroundings. I don't know where else it would go. All right, so energy is said to be degraded through these losses. All right, so we're losing energy. We can't get 100% energy out of it. All right, if we take a quick look at the global energy use, how do we power our cars, our electronics, heat our homes? You can see for the most part, we use oil. Okay, coal is a pretty big percentage, as is natural gas. These are all known as fossil fuels. Small percentage is nuclear power, hydroelectricity, and biomass. All right, and then we have this little sliver that's other renewable resources. Renewable sources are things like solar, tidal, biomass, hydroelectric. Non-renewable would be the coal, oil, natural gas, and nuclear when we talk about fission, which is the nuclear that we use today. Right. There is a YouTube video. I will post it as a link in Schoology, so please go look at that for discussion of energy sources. So useful energy source. What makes an energy source, useful? Okay. One thing is it has to release energy at a reasonable rate. We have to be able to use it at the rate that it releases it. We do like it to produce minimal pollution. It has to be cost effective, has to be widely available, and it has to be sustainable. All right, so if we look at fossil fuels, there is a good release rate. Okay, but it does add to the pollution with the carbon dioxide and sulfur dioxide emissions. And the fact that it's non-renewable leads us questions about sustainability. So how do we put numbers to some of these descriptions in energy? The first one we're going to look at is called the efficiency, and the efficiency of energy transfer. Okay. We have to keep in mind that energy has both a quantity and a quality, right? And that quality is kind of related to that efficiency. Okay, quality gets degraded as we lose energy to the surroundings, typically in heat. All right, to calculate the efficiency, we're going to look at the useful output energy over the total input energy and multiply it by 100%. Just as a reference, coal is about 35 to 40% efficient, and most of that loss is heat during the firing of the coal to produce the heat that turns water into steam, and then the steam turns the turbines, which create electricity. Okay, so energy density. We're going to look at two terms here, energy density and specific energy. Energy density is the energy released per unit volume. We're going to calculate the energy released from the fuel over the volume of the fuel consumed. These units are going to be in joules per cubic meter. Then there's also specific energy, which is the energy released per unit mass. Again, energy released from the fuel over the mass of the fuel consumed. We can convert from energy density to specific density by simply using the density of the material. Okay. Ideal fuels will have high energy densities and high specific energies. Okay. Keeping that in mind, gases typically have low densities. You can improve upon that by compressing them or liquefying them, but that might also create other problems. Okay, and if we look at this side note, oops, don't have it on pen. Okay, if we look at this side note, hydrogen releases 3 times the energy per mass than octane. However, octane has an energy density 2,000 times that of hydrogen. Okay, we can improve hydrogen's density. This is a gas, this is a liquid. We can improve upon that density by compressing it or liquefying it. But what would be a disadvantage of storing a large volume of hydrogen? Give you a sec to think about it. Okay. Remember, hydrogen is a highly flammable gas, so there are some safety concerns with storing large volumes of it. Okay, let's work out an example. We're going to calculate the specific energy of butane using sections 1, 6, and 13 of your data booklet. All right, so 1 and 6 and 13 will give us a couple of different things. What we're going to look for first is the delta H of combustion for butane is negative 2,878 kilojoules per mole. Now we're looking for the specific energy. I want to write up here because I'm going to run out of room. Specific energy is equal to the energy released over the mass of fuel consumed. Now, remember that this negative means it's exothermic. So this number is the amount of energy released. So we're going to pretty much change that to a positive. So I'm going to release 278 kilojoules per mole. And we know in 1 mole there is 58.14 grams of butane. Okay, it doesn't tell us the units, so we can leave it as kilojoules per gram. And if we do that, we end up with 49.5 kilojoules per gram as a specific energy. Okay. Kind of switching topics, we're going to talk about renewable energy sources. Renewable energy sources are defined as sources that can be naturally replenished within a human timescale. So fossil fuels, which take millions of years to make with incredible pressures, underground, renewable has to be within a human timescale, so something reasonable. Renewable energy sources are typically less than polluting than non-renewable, and they are more sustainable. However, their use is limited due to the cost and the availability. There's renewable sources, again, solar, tidal, geothermal, biomass, wind, hydroelectric, and nuclear fusion. This is not what is typically used in a nuclear power plant. They have not really made this work to use as a renewable resource. Here's a table just talking about several sources, both renewable and non-renewable, some of the advantages and some of the disadvantages. You should be familiar with these. I'm not going to read them because it's right there in a table. Okay, so pause, take some notes, and we'll start with the next topic, which will be fossil fuels